Now we'll do an interesting coverage of generator expressions. So generator expressions are a whole other can of worms. They are really awesome worms, and we'll understand that in a short while. So we have all seen list comprehensions earlier. So these generator expressions can actually be used in place of list comprehensions to save memory. So basically, these have been introduced as a high performance and memory efficient generalization of list comprehensions. So, especially they are useful with functions like sum, minimum, or maximum that finally reduce an iterable input to a single value. For example, however long list we might be having, but sum will be a single value, or minimum will be a single value, max will be a single value. In that case, generator expressions are very useful. For instance, let's look at the summation code using the list comprehensions, and what we are doing is x into x for x in range 10. So we are squaring and then calculating the sum of the squares for x in range 10. Now what this will do is this summation code will first build a full list of squares in memory. So if you have a list of 1 million elements, it will first build another list of squares of corresponding elements. In fact, 1 million elements in memory. Then iterate over those values, and when reference is no longer needed, delete the list. Now this takes a lot of memory. However, if we do the same thing via generators, syntactically it's quite similar. We just don't put these square bracket for list comprehensions, rather we simply write it as an expression, and that is why we call this as generator expressions. So it's quite simple, sum of or any function of x into x for x in range 10 without specifying the list brackets. And we'll try to prove through the memory profiling. A lot of memory will be conserved by using a generator expression instead of a list comprehension. Let's try to go to the code part. I'll profile this function, and first let's do it through list comprehensions. So I'll call the function list comprehensions. Let's say this value is equal to sum of, and here we specify the list comprehension x into x for x in range, let's say 1 and 6 zeros for a million, 1 2 3 4 5 6, and then we'll just print done. Same thing we could have done using generator expression, so I'll call this as generator expressions, and this time val is just, I need to write the expression sum of, no list comprehension, so directly the main expression x into x for, I can even copy this part. So this is using generators, and we'll print done again. We'll profile the same. Let's say first we want to profile list comprehensions and call this as profile generator expressions.py and the stuff. Let's do the profiling now. I'll reach on desktop. Profiling of memory can be done by python -m memory underscore profiler and then the file name. This will take little time because of the range. So this is the memory profiling for the list comprehensions case. So we can see that this is taking approximately 71 MBs, we can say, or approximately 70 MBs. However, now we will try to profile generator expressions instead and see using generator expressions, do we get some memory benefit? Yeah. So in this case, we can observe that for this line itself, from around 71 to we have reached to 41 MB. So we are trying to do the same thing, but still 30 MB memory could be saved by using the generator expressions. So that's the reason generator expressions are awesome bombs. Thank you.